given solid. You know already what is meant by specific heat. Specific heat means the amount of heat energy required to raise the 1 unit mass of the body to raise 1 degree centigrade. Yes. Directly proportional to the mass of the body. Means for cooking 1 kilogram rice you need more energy, or 2 kilograms we need more heat energy. 2 kilograms. So if the mass of the body increases, required amount of heat energy also increases. That is why Q is directly proportional to the mass of the body. Right? Next, it is depending upon the change in temperature also. To raise the temperature of the body to 50 degrees centigrade is more, or to raise the temperature 0 to 100 is more. You need more amount of heat energy for which case? Second case. So, amount of heat energy is required more if the temperature difference is more. So, from these two we can write Q is directly proportional to the M into delta T. For removing this proportional, we need to multiply some constant, that is the specific heat. So from this, specific heat is equal to heat energy divided by mass of the body into delta T. So if the mass of the body is 1 gram or unit mass and the temperature, change in temperature is 1 degree centigrade, then the required amount of heat energy is equal to specific heat. Clear? Now we will discuss about the specific heat of how to find the specific heat of a given solid. We need some materials. Materials required: Bunsen burner, wire gauze, tripod stand, and calorimeter, whip stirrer. Solid, given solid it is inextensible thread. Next weighing machine, water and 50 ml beaker, 200 ml beaker, and next one stand. These are the required materials. 2 thermometers. Next procedure. First set the weighing machine to 0 error. Next, specific heat capacity of a material of the calorimeter is equal to S1. It is the given specific heat calorimeter. Weigh the specific heat calorimeter with stirrer, that is M1 grams. That is equal to M1 grams. Now pour the water into the calorimeter and weigh it, that is M2. So the water weight is equal to how much? M2 minus M1. Now kept it into the calorimeter, kept it into the thermal cover, insulated cover. Now find the temperature with the thermometer, that is T1. Wait to record the temperature whenever it gives the stable reading. Now weigh the solid, given solid they gave, right? Weigh it, that is equal to M2. Now tie it with the inextensible thread at the middle of the solid. Now hang it to the. Now take some water and heat it with the Bunsen burner. Next hang one more thermometer to measure the temperature. Now hang it to the Dettol stand, and one end is immersed into the water. That solid should be immersed into the water. Then only it will give the temperature. The temperature of the water and the solid is same. Now heat it. After 5 to 10 minutes, you can remove it. The temperature increases, right? So that is T2 degrees. Note down. It is the temperature of the solid, given solid. We raise its temperature. So quickly keep it into the calorimetry and stir it with the stirrer and measure the temperature again. Yes, we need to be careful to minimize the time when you are keeping into this one. Now stir it well, then the mixture will get the stable temperature. Measure the stable temperature, that is T3 degrees centigrade. Why they are stirring? Because they get the uniform temperature. To get the equilibrium, that stirrer, calorimeter and the water and that solid all get the same temperature. Those all in the equilibrium state. Now observations. First we find the M1 grams without water, only calorimeter and stirrer. Now calorimeter and water, that is M2. So water weight is equal to M2 minus M1. And next weight of this one given solid is equal to M3 grams. Now the temperature is equal to initial temperature is equal to T1 degree centigrade, and the solid temperature we raise it, right, that is equal to T2 degrees centigrade, and the mixture temperature is equal to T3 degrees centigrade. So specific heat of the material of the calorimeter is equal to, if we know that value, that is S1, known calorimetry, that is S1, and specific heat of the water is equal to S, you know that is 1 calorie. 1 calorie for a gram degree centigrade. Now mass of the water in the calorimeter is equal to how much? M2 minus M1. And change in the temperature of the water and calorimeter. Initially that is T1, after it is changed to T3. And the solid temperature is changed to T2 to T3. Initially that is T2, after mixing it, it came to the T3. Now you know that loss of heat by the solid is equal to loss of heat gained by the water and the calorimeter. So amount of heat energy formula is what? Ms delta T. So mass of the solid into, you don't know this specific heat of the solid, we need to find that. Change in temperature is equal to mass of the water into specific heat of the water into change in the temperature of the water plus mass of the calorimetry into the specific heat of the calorimetry into temperature, change in temperature. By changing these values, you will get the specific heat of the given solid. This is about the specific heat, how to find the specific heat of the given solid. Any doubts?